Hey everyone. Well, thank you so much for coming today. My name is Ben, and I'm here to talk about my project that I did with Wolters Kluwer. Um, First off, I just want to talk a little bit about me. I graduated from Boston University in 2020 with double degree in computer science and economics, and now I'm here pursuing my MSBA, Master of Science in Business Analytics, actually graduating in a week. So very excited. Outside of campus, I think the only two again, off-campus job that I have held. The first one is right off of undergrad. I was a front-end engineer for Exporter Technology, which is a B2B e-commerce um, platform that helps connect buyers from America with suppliers from Latin America. And then also last summer actually, I did an internship at Takeda Pharmaceuticals in Cambridge, specifically helping out their cyber and digital trust team with data analytics. And I just wanted to put my two cats here because they mean the word to me, and like they're kind of like my charging station whenever I get off from work or like from school. Um, Left is Poe, and then on the right side is Ban. Ban's birthday is actually tomorrow. He's turning 4. Um, yeah, so the problem, last semester, Wolters Kluwer came to Mark with this problem. They basically say that, hey, we've been spending a lot of time doing this project estimate. I think each estimate session took about like an hour to two, and for each project, they conduct multiple sessions like such. And now we're sitting on a bunch of project estimate data. How would you like to come in and help us use this data in order to help make this process more efficient? So a little bit more of context. Last semester, I actually did a Monte Carlo simulation to help them simulate project estimate using historical data. And that is what is showing on the right. And then this semester, we wanted to explore other tools and other basically models to also help estimate project story point. And that brings us to the multiple linear regression model. And here is my 4-step approach to building out a regression model. I think step one, super important, is data collection. When someone comes to you telling you that they're sitting on a bunch of data, know that most of the time it's not in one place. So all their project data were in separate tables, sometimes on Jira, in a folder somewhere. So I had to do a lot of data aggregation, meaning I had to personally go out into these files, into these web pages to collect all the data that they had available into one Excel spreadsheet that I can use to then build my model. And then one thing with building a regression model, in case you're not familiar, is that you're building this model based off of a bunch of variables. And so we had this brainstorming session where we came up with tons and tons of variables. Some of those they already had data on, and some of those they actually did not. So what ended up happening was I had to go out again and collect more data. So it was a cycle of maybe 8 to 12 weeks of just brainstorming and then a lot of data collection. And then once I had all those data in one place, the second step is transforming all those data into a suitable format for my regression analysis. Specifically, I think more sophisticated tools can automatically handle this, but with Excel, you have to transform categorical variables, specifically text variables, into numerical values so that they can process it. And then once all that is done, step 3 is building the model. With regression analysis, building a model is pretty straightforward. You select all your variables and then you run the regression. However, this took some time because with Excel, it was a trial and error kind of method where I had to cycle through different combinations of variables to hopefully get the best model. And I'll show you what that means in a second. And then lastly, of course, getting your best model isn't the final step. It's also turning it into a form that the team can use, specifically for like future project estimation, and then also documentation, whether it's in written or video form. This is crucial, of course, to make sure that once I, end my time with the company, someone can come in and they would have all the resources needed to pick up this project where it's left off. So yeah, we'll dive straight into some snapshot of what the project looked like. This is the master data table where I aggregated all the data. Each row represent a single project that they've had an estimate done on, and then you can see that each column is a variable that we're interested in. There's time, estimated length of project, the risk level, the teams that were involved, and then whether each project required front end or back end work. And so this is what I meant by I had to transform them into a format suitable for regression analysis. You can see that the column that used to be on the left, listing all the teams that is involved in a project, is now transformed to a series of columns on the right that are binary variables representing whether or not each team is involved in that project or not. And so, yeah, I began running a bunch of regression analysis. Clearly, I think to you, this is just a bunch of numbers, and it is clearly very overwhelming. However, let me help you out here. There's only a few numbers that truly matters in this output. We have the adjusted R-squared, the standard error, the S statistic, and then also the p-value associated with that S statistic. And then lastly, the coefficient for all the selected variables, and then the p-value associated with all those coefficients. Of course, I'm not here to give you a crash course on regression analysis. However, I'm gonna just quickly tell you that adjusted R-squared, the higher the better, standard error, the lower the better, S statistic, the higher the better, and then all your p-values, if we want a really good model, we want to basically minimize our p-value, keeping it under 0.05. And then 0.05 is basically just a number that data scientists call this coefficient to be statistically significant. Yeah, so I cycled through about 20 plus different combinations of variables to find out my best performing variables. I'm sorry, my best performing model, which take us to this one. So you can see here the adjusted R-squared went from 0.35 to a 0.51. And even though with a lot less variables, this one is like clearly performing better. You can see that the p-value are all under 0.05. Again, this means that all our variables are statistically significant, and what we have is basically a usable model. Just to compare, I'm gonna go back to my first model. You can see here, again, all the p-value are actually really close to 1, again, which is an indicator of a pretty bad model. Yeah, so of course, again, getting that final model is not the last step. It's also turning it into a form that can be used by the team. I did some work and of course, cleaning up all those extra decimal points, highlighting like all the numbers that were important to the team, and then added this section down here that basically just shows the team or any member going into this spreadsheet what the full formula is, and then a table that basically just simulate this regression. You can see in this output here, the member can enter a value for each of the variables, for example, number of team, risk level, whether front end is required, and whether each one of these 3 teams were involved. And then our regression model will spit out a estimated story point with a lower bound and an upper bound that is calculated by the standard error value up there. Yeah, and then that's pretty much it. Some key takeaway that I've learned from the experience, I think number one, data collection and preparation often take a lot more time than model building. Again, especially for someone who's coming into the company as an intern, onboarding takes a lot of time. Like Lucas said, like getting access to all these different data sources is also pretty time consuming. However, again, this is like super crucial because you want to have quality data before you go into start building your model. And then secondly, not all data is equally valuable. Identifying the most predictive features is very important. Like you've seen I think in the master table, I had roughly 20 rows. However, in the final model, there were only about 5 variables that are used. So yeah, all data I think has values, but however, not all data are equally valuable. Third, employer solution that your team can maintain and understand. Personally, I am I would say I'm a Python and R expert. However, for the use of this project, of course, they actually had asked me if I can conduct the analysis in Excel because, again, for a typical analyst, they might not be as technology advanced and understand like Python or R code. However, it doesn't mean that I didn't cheat it and at some point still wrote out some R code and Python code to do this project. And then lastly, the most complex model isn't always the most effective. More variables doesn't mean you're gonna get more variables isn't always the best. Also, I think linear regression is a pretty simple model. However, for this project, it actually worked pretty well. Yeah, thank you for listening. Just a quick shout out to Mark for giving me this opportunity, and then Brian and Brad from Wolters Kluwer, who have been working with me since September of last year. Thank you.